if we're talking about rational numbers, we're talking about fractions and decimals, okay? So that's what we're going to compare in order today. So we're going to start off talking with decimals, how to deal with those, decimals. And we're going to look at these 4 decimals and see if we can compare them. So we have this first one, and I'll just list them out left to right. And who can read these numbers for me properly? Who could read them the way they're supposed to be read? So I would not read this properly, 2.05. That's not how I read it. I actually have to say it a different way. William, go ahead. Let's start with the leftmost. How would you read that? 2 500ths. How would you read this one? Negative 25, thankfully. This one? Negative 2 5/10. And last? 205 thousandths. Okay, so if you can say those, that'll help you out in these problems. But I said these are decimal numbers, and I believe that about 3 of the numbers, but there's one that I'm not sure of. Which one do you think I'm not sure of about being a decimal? Oops. Wait, oops. Drew?
Negative 25.
Oh, that's not a decimal, is it? Hudson?
It can be. You can put a point, you can put a decimal point and then use 0.
Okay, now if I put a decimal point here, Hudson or anyone else, did I change the value of that number? No, I just put a decimal place or decimal point there, and then you can add zeros if you want. Negative 25, as it is written, is a decimal number. You're like, but where's the decimal? It's right there. Do you guys remember when you divide? And sometimes you have to put a decimal point in that number? You do that in the box because you want to keep going out in the decimal place value. So they're all decimals. They're technically all decimals. All right. How do I order them? And we're going to order from or we'll go with least to greatest. Okay, now your book gives you a number line, and you're more than welcome to look at it through a number line, but you don't have to do it, especially with decimals. It makes it nice that you can compare them using something else. Okay, but we're going to order from least to greatest using place value. So do you know how William and then myself, we were reading it 2 500ths, negative 2 5/10. The reason I do that is because if you really understand what the numbers are, like you know how to say it properly, then you actually can order it very quickly. But if you don't, let's look at another method to see how you can compare those. All right. I'm going to use this next screen here. All right. I'm just going to write those numbers, and I'm going to align them by their place values, which means I'm lining up the decimal points. So first one's up there. What was the next number? Negative 25. All right. Negative 25 would go right here. And then Hudson said, yep, you can add zeros after that decimal point. And then what's the other number? Number 3. The third number? Negative 2 5/10. Good. Negative 2 5/10. And I want to add a 0 to make it like that. Fine. And then the last number, 205. 205 thousandths. Good. Okay. Are the signs correct? Both of these are negative. The other two are positive. Does it matter, by the way? What do you think? Does it matter if they're negative or positive? Whatever. They're the same thing. No, they're not the same thing. You compare them the wrong way when you don't have those negatives. Okay. If you're thinking of your number line, here's how I'm going to make the illustration happen. I'm a big fat 0. I'm 0 on the number line. All the numbers for you guys to your left would be positive or negative? Negative. And all these numbers over here to the right for you would be positive, right? So as I go this way on the number line, further and further to the left, what happens to the value of my numbers?
Lower.
They get lower. As I go to the right, they get
Higher.
So if you need to do this mentally as you're comparing these or other numbers, you can do that. But here, we're just lining up place values. I'm going from least to greatest. Which numbers should I consider first? Automatically, I should start thinking about these, even without comparing. Right?
Negative.
The negatives. These two got to come first. Because if they are negatives, they should be further to the left. But which one should come first? Drew?
Negative 25.
Negative 25. Now, when I write my answer, I write it the way they gave it to me. So, did they give me negative 25.000 or 0.000? No, they gave me negative 25. That's how I write it. That's my first number. All right, that one's done. Which one's my next number? Don't think too deeply about this. Yep, Henry?
Negative 2.5.
Negative 2.5, negative 2 5/10. Good. That one's out of the way. All right, that one's not too bad. But now let's look at the other two, which are positive numbers. Which one would come next from least to greatest? Natalie?
2.0. Oh, from least to greatest.
Least to greatest, yep.
0.205.
0.205. Or 205 thousandths. And then your life just got easier. Last one's going to be 2 5 hundredths. Notice how I wrote it the way they gave it to me in the book, and that one's done. This is my answer, least to greatest. On your papers, I'm going to say L to G. Like if I correct you, L to G means you didn't do least to greatest, or you need to do least to greatest, depending on what it is, but least to greatest to kind of make it simplified. Okay, you guys good on that? It's not too bad, right? I like decimals and comparing them because you just go decimal place value. Yep, Alex?
Is the last one, should the 5 be before the 0?
Oh, sorry, this one?
Yeah.
The 5 before this. I think it's this one, right?
Yeah.
So is it this one you're talking about?
Yeah.
Yeah, like on here. I think we have it written down wrong.
Oh.
Wait, never mind.
No, that's okay. I want to make sure we get it. Are you guys okay?
No, it was negative. Yeah.
Okay, so yeah, the negative 2.5 is right here, and then that's 2.05. Is that okay? We're good. That's okay. I make mistakes, by the way, so don't feel bad if you're like, wait, Mr. A, is that how? We can correct it. Okay, all right. So we're good with decimals and ordering, and I hope you guys are good with the place value. I think that's pretty straightforward. By the way, some problems are going to say least to greatest, and what might other problems say? Greatest to least. And you're like, Mr. A, it's a mystery. How do you know it's going to be one or the other? What's going to tell you? The directions. Mr. A, do we do least to greatest or greatest to least? Did you read the instructions? Oh, yeah, I don't want to hear that today. Is that cool? Yeah, you're like, no, it's not. Okay, just read the instructions, you'll be fine. Okay, let's look at fractions now and comparing. So we're talking about fractions. These are not too bad, but they can get really tough, especially when the values are so close. So fractions, and this can include mixed numbers as well. Let's start with 6 2/3, 6 3/4, and 73/12. So these are the three numbers, and you know what? Let's go greatest to least. Greatest to least, which I would put from here on out G to L. Greatest to least. Okay. Two numbers are mixed numbers. The third one is an improper fraction. Can I make it a mixed number?
Yeah.
Can I make that third one a mixed number? How do I do that? Because you're going to have to do this on your own. How do I make 73/12 to a mixed number? Real quick. Yep, Sam?
Figure out how many times 73 goes into 12.
Yeah, how many times 12 goes into 73? How many times?
6.
6 times with the remainder of? So 6 1/12 is what we would get. So I'm just putting that parentheses so we know what number it is. Okay, great. There are many ways to do these problems, by the way, but you need to show me something about what you're doing. If you just do it in your head, I don't know what you're doing. You're like, but Mr. I use mental math. But there are many ways to do mental math, so just show me what you're doing. Okay, how would you handle this problem, somebody? How do you go from greatest to least? How would you do it? Darius?
You could change it to decimals.
Okay, one way to do it is to change these mixed numbers into decimals. That's exactly, you could totally do that. And then you can compare them like we did the last problem. Good. What's another way? William?
To find the least common denominator.
Wait. William, hold on. Time out. That was last week's stuff. Are we allowed to use last week's stuff today?
No.
Yes. Yeah. Of course not. Okay, you want to get these fractions so that you have a least common denominator and you can compare them right away. That's another way to do it. Is there any other way to do it? Yep.
You can like draw them out.
Okay, you can actually, many ways to even draw it out, but maybe you could do like a number line and you could put 6 and 7 and then, all right, where would that go? Where would that go? Okay, and then order them like that. Perfect. Any other way? Yep.
You can just do your common denominator.
Okay, your common denominator, kind of like William said. Okay, guys, we didn't even talk about them all, but this is what I don't want you to do. Mr. A, I did it up here. I already know the answer. Boom, got it. Don't do that. Because when I look at the paper, you got it right. How'd you do it? I don't know. Look at the paper, you got it wrong. How'd you do it? I don't know. Do I know either way? I have no clue. So make sure that you save yourself some heartache. Because on the quiz and test, if I don't know what you did and you got it wrong, you lose all the points. Every point, even if you're just off a little bit. Because I had no clue what happened. Okay. So we're going to go with the least common denominator because I think that's what most of you would do. Not all of you, most of you. So what is the LCD of these three, I should say, these three fractions? What's the least common denominator of 2/3, 3/4, and 1/12? Yep, Josiah? 12. So I need to change this mixed number so that your denominator of the fraction is now 12. So what do I multiply the fraction by? Anyone know?
4.
Okay, thank you. 4 over 4, which gives me 6 and 8/12. Okay, we're okay with that? 6 and 8/12. All right, what do I multiply the fractional part of 3/4 by to get that 12 denominator?
3.
Oh, thank you. Guys, I haven't had I ate breakfast a long time ago. Lunch is still coming up. So any things that you say that are hard on me or math in general, they hurt, guys. They really hurt. I can't take it right now. Do you understand?
No.
No.
Okay.
Now I don't understand.
Sorry. It's like okay, I'm done. Yeah, go
I
ahead.
don't understand why we multiply 6 and 2/3 times 4 over 4.
So really we multiply 2/3 by 4 over 4 because we want to do the common denominator of 12.
Oh, okay. So that makes
Same thing. Yeah, so in order to get the final part here. All right. Do we have to multiply 6 and 1/12 by anything? No, because it already has a common denominator, so you saved yourself a step there. Is it pretty clear now which one's the greatest? I mean, it's very clear. Okay, if you are listening to me, tell me which one's the greater. Write it in my answer. Which one's the greatest number? How would I write it as an answer up here? So what's the greatest one? Yep, Anna Grace?
6 and 9/12.
So you're correct, as in you know the right value, but how do I write it in my answer? Yes, Hagen?
6 and 3/4.
6 and 3/4. So I want you to write it just like I wrote it in my, just like they gave it to you in the problem. So you got to write 6 and 3/4 in this case. Therefore, what would be the next from greatest to least? Excuse me. Yep, Drew.
I can answer it, but I have a question.
Go ahead.
6 and 2/3.
Yeah, you got to write 6 and 2/3, the way they gave it to me.
And
Okay.
on a test, if we accidentally do like 6 and 9/12, will we cut off?
Just a point. Yeah, and like the problem would be 4 points. You lost a point, but not all of it. Taking it all. Yep.
So I'm still a little confused how you did that. So why 4 though?
Yeah, good question. Like, why did we pick 4 over 4? Why did we pick 3 over 3? Like, why do we just pick numbers? Well, how do I make 3 turn into 12? I multiply it by 4, so I'm going to multiply the fraction by 4 over 4. How do I make 4 turn into 12? I multiply by 3, so I pick 3 over 3 to get that common denominator.
6, or how'd you get 12 as the denominator again?
That's the LCD of 3, 4, and 12. That's the smallest number that all three of them fit into.
So you find that first.
Then you know, all right, I'm starting to look for that number. Yep.
Okay.
Yep, that's right. All right, and then last number. 6 and 1/12? Hudson?
73 and 12.
73 over 12 is what I write. Got to write it the way they gave it to me. Okay? Guys okay with that? because it's going to happen. You're going to see it. You're going to have to do it that way. That'll help me to know that you understand the numbers themselves. Okay. Almost done, man. Almost done with that. Last thing we're going to do today is comparing compared to fractions. So we talked about ordering, so least to greatest, greatest to least. Now we're going to do comparing two fractions. And you can extend this to 3, but we'll just do 2. Okay, 7/9 compared to 5/7. Okay, when I'm saying compare, what I mean is which one of these symbols would I fill in this spot with? But what is that symbol? I forget. What's that symbol right here where it points to the left? Darius?
Greater than, less than.
Okay, which one is it though? The way, if I read it left to right, if I read it from here to there.
The bottom one's greater than.
Okay. Okay, this one's greater than. And this one's less than. All right, so I would read it, this number is less than the second number. Or this number is greater than the second number. So you got to know which one it is. Because they're the same thing, right? No, they're not the same thing. Because then, I don't know why I'm giving you these problems. You can also get equal to, okay? You can also do equal to, which means equal to. Okay. How would you do this problem? Tell me what you would do. I think we came up with the last class, we came up with 5 ways to do it. Okay, go ahead, Drew. One way.
LCD.
Get the LCD, change the fractions with that common denominator. You can compare them. Good. What's another way? Yep.
Draw it out.
You can actually draw out 2 like rectangle circles, shade in 7/9, shade in 5/7. That's good if you're really good with drawing. Because if you mess up the drawing, if you make it look too big or too small, it throws you off. But you can do that. What's another way? Yep.
The cross products.
Oh, cross products? Is that written in there? Uh-oh, yes, cross products. That's another way to do it. Good. What's another way? That's 3. They got 5. I helped them out with 1.
Help us out with 1.
Oh, yes?
So I have a question.
Oh, go ahead.
So how would you be able to do it if you found the LCD? Or is it LCM?
So it's the LCD. So you want it of 9 and 7,
Okay.
which would be your 63. You can use that. Mm-hmm.
Calculator.
Okay, technically you could use a calculator there. There are a couple. Come on, guys, let's see. You can make these into decimals, and then you can compare the place values.
Can you help us with that?
Yeah, so you get the 5. Well, the calculator, I'm a little iffy, but that okay. I'll count it. All right, I'm gonna give you my way after we do it the way we're gonna look at it today. But those are all valid ways. We're gonna use cross products. Okay, cross products. It was funny because someone in the other class, they were explaining it. So, all right, what would you do? And they're like, I would do this and this, then this and this, and then you do this, and then you do this and this and this, then you do this and this and that. And honestly, I lost them at the first part, but I believed what he was saying. And then a lot of people were kind of lost, which is okay, because that's a long process to speak out. But with cross products, it makes it really straightforward. And listen carefully on how I do. I'm going to do it twice here so you guys know what I'm doing. Okay, I'm going to compare these two using what we call cross products. What does product refer to in math? Multiplication. So this is what I'm doing, guys. Ready? I'm going to multiply this top left number, the first numerator, by the second denominator. So 7 times 7 is? Yes, 49. Good job. And then I'm going to multiply the first denominator by the second numerator, which is hard to say, by the way. 9 times 5? 45. Okay, then all I have to do is say, all right, what's the comparison symbol between 49 and 45? What would I put here? Greater than or less than or equal to?
Greater.
Greater than, right? Therefore, this is a greater than 2, and that's the answer. Oops. Is that too easy?
LCD?
Yeah. That's okay. Yeah, you could do LCD. You could do LCD cross products, drawing them out, decimal. But how would Mr. A do it?
Cross product.
No, I wouldn't do cross products on this one. No. No.
Algebra? You would use
No. This is what I would do. And honestly, I'm not expecting you to do what I'm going to do now, but this is what happened. I'll get your question in just a minute, Anna Grace. I went to a math conference last year, and it was mainly for, it was about fractions. A day about, or 2 days about fractions. You're like, what can you talk about fractions for 2 days? It was really cool because it was mainly for elementary, but then they did some for middle school, and they said, you know what, a lot of our kids, including myself, we don't even know what this means. We don't even know what 5/7 and 7/9 mean. I'm like, I don't know, these guys are pretty bright in here. But 7/9, okay, think of that, and 5/7. Kind of get a picture of what 7/9 would be. You could think of a pizza, you could think of a rectangle, whatever. Okay, but here's how I do it in my head. You don't do this if you don't get this. I totally am okay. Okay, 7/9 right here. Can you kind of picture that? 7/9 has a little bit missing, right? How much is missing from 7/9 to make a whole? 2/9, right? 2/9. Keep that in your head. 2/9. All right, how much is missing from 5/7 to make a whole?
2/7.
So I have 2/7 missing here and 2/9 missing here. What's bigger, 2/7 or 2/9? 2/7 is bigger. So isn't this number missing more than this number? Greater than that number. So you can do it using mental math, but if you don't get that, it's okay. You don't have to, Mr. I didn't get it. It's okay. But that's using what we call number sense, and you build that up little by little. You're like, Mr. A, isn't this, and there are so many, there are actually 3 other ways I could teach you, but this is a good way. Cross products is nice. Okay, let me do one more so I don't lose you guys. And this is where people get even more confused because of, what is it? The negative sign, the one we don't like very much, but it's super useful. Okay, so we have these 2 fractions being compared. You could turn them into decimals, get LCD, or you could do cross products, or you could do mental math. Okay, many ways to do it, but this is what we're going to do. We're going to use cross products, but what's different from this problem and the last problem? Negatives. Do those matter? Yes. Oh my.
It doesn't mess up the multiplication.
It does it in one sense, but then you'll see what I'll show you what the common error is. All right. I'm going to take the first numerator and multiply it by the second denominator. 6 times 9? 54. I'm missing something.
Negative.
Okay. It's critical. That's a critical error if I didn't put that negative. You'll see why. All right. And then I take the first denominator by the second numerator, and I get? Good. 22 negative, right? Okay, what's the comparison symbol between these two? Negative 54 is what to negative 22, Andrew?
Less than.
Okay, less than. Whoa, wait. I thought 54, and see, listen to my question. I thought 54 is bigger than 22. Negative 54 is smaller than negative 22. Here's my number line. Okay, so you got, is that cool? So what would be the comparison symbol between these two?
Less than.
Less than. Now, here's the error. So everyone put this down. Don't put what I'm going to do now because this is where people mess up. What's the comparison symbol here? So greater than, right?
Yeah.
You see where the negative signs mean something here? If I don't put them, I get different numbers. It switches it actually the complete opposite way, which is not very good.
It's pretty easy. So when you do this, you just do the same process. You just think about it, whichever one looks larger. If you ignore the negative, that's the one that's less.
Okay, yeah, if you want to think of it that way with negatives, that's fine. Okay, let me give you a couple problems you need to do on your own to make sure you guys are good, and then I'll give you your homework. You'll have the rest of the time. So, I want you to compare these two numbers. I'm going to label it number 1, and you guys are comparing this and this with a couple little symbols added.
What?
Don't call it the answer. Work it out. Give me which symbol should go there. You're not supposed to give it. So stay quiet. I'll get Hudson to give it to me after you guys have done it. You're like, Mr. A, we don't need to work it out. Well, I would look at it more closely. And I did it. Hopefully I didn't mess it up. Like I wrote it exactly the way it's in that book. So.
I think I know the answer.
Okay, so you'll give it to me in just a moment, Hudson, and then I'll show you how I did it. Maybe Hudson did it. Okay, Hudson, what'd you get, or what'd you do? How'd you think of it? All right, listen up.
What I did is, well, if you did, a 6 and 2 repeating,
What repeats here?
0, 2.
Sorry, for this one?
They're saying because if you repeat them,
Mm-hmm. What does that one look like? What repeats? Okay, Alex. Those are the same, right?
No.
Sorry, 6 and 6 right here.
Yes.
Okay, the tenths place are the same.
Yes.
The hundredths place are the same. Wait, they're the same number. What about the thousandths? So this number is bigger. So it's a greater than. Oh. How many of you, honestly, and you don't have to call out, but you thought they're the same number at first? And yeah. And then when you looked at it, when I said look at it more closely, or you figured, oh, you're like, whoa, you realize, wait, that repeating bar is over 2 digits, only over 1. Therefore, it would make it look something more like that. How many of you could get it's greater than? Could get greater than on your own? Okay, just write it out and compare place values, and then hopefully it's not too bad. Okay, next one is comparing these two mixed numbers here, 2 and 5/11ths, and you're going to compare that with 2 and 3/14ths. Uh-oh.
Oh, no. Wait, number.
Yes. You want to give me the answer, Michelle? Oh, okay. Sorry. Looking at it, guys, don't be too. There are many ways to work this out. I'm going to give you hopefully an easier way, and you'll be like, oh, I didn't know, or yes, we could do that. Okay. Do you guys notice anything about their place value? What did they both have in the units place or the ones place? What do they both have? They both have a 2, so they're the same in that way, right? So am I not really just comparing their fractions?
Yep.
So some people are going to do this. They're going to make this an improper fraction, make that an improper fraction, and then get common denominators. You could do that, but you get these big fractions. Why don't I just look at the fractional part, and then cross products. So it's 5. Remember, 5 times 14. 70, 11 times 3, 33, greater than, which means this is greater than, which means that's greater than, it's a greater than.
Greater than.
Could you make these decimals? And would you still come up with the same answer of greater than? If you do it right, you should, but it just makes it a little bit tougher, I think. Okay, last one, and then that's it. You're done with the classwork. I'll give you the homework after. You guys ready for this one? Of course you are. I'm going to label this. I know it's not number 4, like it's the third problem. I'm just going to call it, because it's coming from the book, negative 3.3 or 3 3/10, negative 3 1/3, 3 3/10 with the repeating bar, and negative 7 halves, or negative 7/2. I want you to give it to me from, what does that mean?
Greatest.
Good. L to G. You're like, what's that? Least to greatest.
Well, that's the name.
Now, you have fractions and you have decimals. Or you have a couple fractions and a couple decimals. Man, what do we do with that? You can make them all fractions. You can make them all decimals. It's whichever one you prefer, but which one's going to be easier, you think?
Cross product.
Decimals. Decimals tend to be the easiest. Now, Darius, you did mention cross products. You technically could do that. You can compare these numbers, but you just have to do it many times. So, I mean, it's possible. All right, negative 3 3/10. I want to make sure I didn't miss a bar. Okay, we're good. That's a decimal. What would negative 3 1/3 be as a decimal? Sorry. Negative 3.3 with the bar over the 3. Yep. And you're like, how'd you get that? Well, what did you again, two ways you could do this. Get it 10/3 and then divide it. You should get that. The 3 would keep repeating. You just divide. All right, this one's already there. Oh, but the negative sign doesn't matter, right? Good, wrong. It does matter. And then what's negative 7/2 as a decimal? I think I heard negative 3.5 or negative 3 5/10. Okay, so I have these numbers right here, okay? All right, so that was not super helpful for some of you. Like, that didn't help me. Which one's the smallest number out of those numbers? I'm talking about these four. Smallest number. What do you think? Yep.
Negative 3.3.
So I'll ask, is it the 3 without the bar or with the bar?
Without the bar.
Okay, but there's another one that's smaller than both of those. Because it's more to the right, or more to your left. Okay, Eva?
Negative 3.5.
Negative 3.5 is the smallest one. So how do I write it? Negative 7 over 2. Negative 7/2. That's my first number. Do you see how negative 3.5 is smaller? It's a little bit more to the left. Okay. Whew, that one's out of the way. Done. But which one would come next? And again, we're dealing with negatives, so it makes it tougher. Josiah? Okay, so you're saying this one, which is negative 3 1/3. Whoa. They're the same thing. Well, look at the 3. Doesn't that mean it keeps going out? So like some of you are like, what are you talking about? Okay, the second one right here, wouldn't it be ... And this one would be ... Okay, they both have the same whole number. Tenths. Oh, this one's bigger in absolute value, but because it's negative, it's smaller. So that one's it. Does anyone need that?
No.
All right. And that one's done. What's next? Andrew?
Negative 3.3.
Negative 3.3. Done. And last, but not least, literally. And William?
3.3 repeating.
3.3 repeating. That would be my answer. And I wrote them out the original way. All right, guys. It's up to you now. Don't forget about negatives. They do change the value. Okay, let me write the homework down. 13 to 31 odd. And number 38. Coming from pages 9 and 10. That's your homework due tomorrow. You have time. Use it up.